You've boarded a new type of air taxi to ride across town for an appointment. There are a couple of other passengers sitting next to you in the sleek electric vertical takeoff and landing vehicle. But wait, where's the pilot? Who's flying this thing? Well, simply speaking, it's a computer developed based on years of learning to advance automation in the flight deck. Autonomy is coming to air transport incrementally, even as many are still wondering how it really works and how it will be accepted by regulators and consumers alike. Well, to help make sense of this exciting, but to some daunting prospect, FutureFlight spent time with independent expert Sergio Cecutta to talk us through the path to autonomy.
When we are talking about pilot, the truth is there will always be a pilot on board. It's just the difference is the pilot won't be human anymore. It will be a piece of software, but there will always be a pilot on board. The big push for autonomy is definitely the cost savings. So the pilot is one of the cost centers in operating cost of any aircraft, including any eVTOL. And a McKinsey study said that a piloted eVTOL has doubled the cost of one that's autonomous. And to add more, just to give a little bit of an idea of numbers, Kitty Hawk, another company in the eVTOL space, believes that if you have one remote pilot overseeing 5 aircraft, you can reduce the cost of the pilot to less than $1 per mile. And then you have to imagine, we know that the lower the price of the service, the more the affordability for an increased number of people. And so one of the ways to bring this to the point of become a new form of mass transit is to reduce the cost. And part of that roadmap is to actually transform the pilot from a person to a piece of software.
To be clear, no pilot on the aircraft doesn't necessarily mean no pilot at all.
In the classic way that we thought about remotely pilot, like with the first UAVs that came out, there was really someone flying the aircraft. It's just instead of being on the airplane, it used to be in a control station. However, that it's still a one-to-one, one pilot, one aircraft. And so the idea with remote piloted is that you have someone in a remote location that oversees multiple aircrafts and intervenes only if he sees conditions that are off nominal.
The companies focused on proving that autonomous flight can be safely achieved aren't rejecting the core principles of what the pilot does. They're just trying to find ways for machines to handle all or some of them to varying degrees.
And let's talk about the 3 main tasks of a pilot when it comes to flying. And it's aviate, navigate, and communicate. So aviate, it's the actual control of the aircraft. And when it comes to an autonomous system, it means interacting with a digital system that can control the entire airplane. In this case, a fly-by-wire system. The other piece, it's the navigate. And it's not only following a flight plan, but also avoiding obstacles, whether they are other airplanes, whether it's terrain, construction. And in this case, we're talking about the introduction of sensors in order to do detect and avoid. So it's basically looking. And there's cameras, there's many other sensors, millimeter wave radars. And one of the new sensors that is finding application that's coming from the car world, it's LiDAR, where a company named Luminar, that is one of the most advanced companies in the LiDAR sector, is actually doing a test with Airbus to install LiDARs on helicopters and aircraft. Last but not least is the communicate. And communicate means the machine needs to communicate with ATC because the communication needs to be there. And in a certain sense, with the introduction of CP/DLC, the communication is already moved to text-based. However, we still haven't defined what happens to the part where we actually talk to the ATC. Is it going to be a computer voice that talks to the ATC? Is it going to be all data-related exchange? That's the part that is still being worked.
And artificial intelligence, machine learning, and what's called deep learning are building blocks too.
Artificial intelligence is basically a broader concept of machine that emulates the performance of a human. When it comes to machine learning is an application of AI with the idea that if we give machines access to data, they can learn for themselves. That is a little bit how we interact with the world. We are given data as a baby. You are given a spoon or something you didn't have. And last but not least, there is also one last concept that is deep learning, that is basically an application of neural network, so very powerful computers, to machine learning in order to learn and understand the surrounding world.
Ever more sophisticated communications networks are a big part of the equation to support autonomous flight, from your cell phone to the cockpit.
The majority of these vehicles will operate in cities and around cities. And so we've heard many times this 5G as an enabler of new functionality. And 5G is actually a very high bandwidth connection. And so in this case, for many of these vehicles, we're looking at 5G as a way to connect. However, we always need to be aware of the fact that this connection might drop. And so aircraft will have to have system on board to allow the aircraft to continue operating in case there is a dropout, for example, because you're between buildings. But in general, 5G is one of the enabler of this next generation of aviation. And considering the time frame we're talking about, it might even be 6G. Until now, many times, up to 4G, there were very few critical applications that ran on wireless networks. With 5G, more and more applications are running on wireless network. 5G is also the way that they're thinking for communication between automated vehicles. And so even 6G, there is more and more of a focus towards how do you do redundancy, how do you ensure that the probability of a lack of signal becomes very, very unlikely.
Regulators aren't going to just let the industry fast forward to full autonomy. Among the questions that agencies like FAA and EASA are considering are how will machines make some of the tough decisions that we've counted on pilots for since the Wright brothers took to the air on a beach in North Carolina more than 100 years ago.
When it comes to all of this, the idea is that it will do everything that a pilot does, and because of machine learning, because of deep learning, it will have learned how to fly. In this case, we used to talk about driverless cars. We still talk about non-piloted aircraft, but we're moving to autonomous aircraft. And Waymo, that is one of the most advanced companies in the autonomous car world, now talk about the Waymo driver. And I think we will have something similar to a Joby pilot, an Archer pilot, because each company will have its own software that will learn how to fly. And so you will see that each aircraft will be a specific way of flying. All of them safe, all of them certified to regulatory standards, but we'll see this emergence of this pilot according to how each and every one of the different company trains it. But again, always safe, secure, and there is one more item that we not consider many times for software, and it's ethical. Because in this case, if we have no humans, there is ethical decision that needs to be taken into account. If you have the case in which you have very low visibility, a pilot would decide we're going to divert. And in this case, for example, a principal might say, no, but I really need to land there. And the decision is the pilot says, no, we are going to be safe only if we divert. And so we can see something similar when it comes to ethical decisions made by an aircraft. All the way ultimately to the famous car question of you're on a 2-lane road on a bridge, and now you can either go into the water or go and crash into a bus with children. Which one are you going to go for? These kind of extreme decisions as well. So when it comes to autonomous flight, it's going to be a gradual process. We'll go step by step all the way to full autonomy. And one of the first steps is this SVO, the simplified vehicle operation that we hear for eVTOLs, that basically what it says is tries to automate more and more functionality so that the pilot is not called into some specific situation as the person that needs to solve the issue, but the system tries to solve issues on their own as much as possible so that the pilot needs less training in order to operate the vehicle.
The fact is that there are already increasing degrees of automation and autonomy in technology supporting our daily lives, and we barely notice some of these. But keeping passengers on board with this idea, literally and figuratively, when it comes to flying, cannot be taken as a given.
There is already a lot of autonomies around us. There is subways that are automated. In airport, there is the little people mover train that are completely automated. There is more and more autonomies in our life, and the more autonomy there will be in our life, and in this case I'm looking at automated vehicles, the more people will get comfortable with the idea of a machine steering another machine. Any one of us that's tried autopilot, in autopilot is not a system that drives on its own. It's a driver assistance system, but at the same time, when it works, it's really great. The other piece of the puzzle we need to look at the acceptance from a generational point of view. And when we look at surveys, the younger generations, in this case Gen Z and Millennial, are more willing to fly autonomous aircraft than older generations. And so the other part that we see is that there is going to be more and more of an acceptance from younger generation that can then make other generation more comfortable with the idea of flying an autonomous vehicle.
In addition to all of his years of experience in the aviation sector, Sergio has closely followed the implementation of autonomous technology in the automotive sector too. And he's convinced that this is a big part of the coming advanced air mobility revolution, just as it has been with cars like his own Tesla. AIN's new FutureFlight.aero platform is drilling down into complex topics like autonomy to make sense of the new aviation technologies and business models. We're posting fresh news day by day. Subscribers get access to exclusive stories about what's happening throughout the industry, and also to our extensive database of new aircraft programs and the companies behind those. You can subscribe for free to our weekly newsletter, which brings you highlights from the Future Flight world every Thursday. We'll be posting more of these videos explaining the context for advanced air mobility, so thanks for watching this one, and please do find more of our coverage at futureflight.aero.